learning in database world, right? I mean, what we are doing with that machine learning process and how we are consuming this data in a real life scenario, and we'll go with some demo too. And we have a powerful server sitting in the University of Oregon, which Ganesh and Dr. Samir set it up. And we'll go with a small demo at the end of this presentation and see how it's getting consumed. So just to start with the machine learning, right? I mean, so this again, machine learning is not new. It exists till 1959, right? As the author Samuel once said, it's again a study of gives computer the ability to learn without being explicitly programmed, right? I mean, we are teaching the computer what to do based on that large number of data set. And we already went through a lot of presentation on big data, the volume of data. We are getting more and more data is coming in, and with the metaverse is coming up, we'll be needing very, very powerful system to process, the data in the real world scenario. So again, all I want to say is this is not new; it's just existing since 1959. Right? So when you look at the data, right, one of the surveys says all these machine learning projects like consuming data, 66% of data is coming from RDBMS, relational database. So the thought is, if the data is sitting in RDBMS, relational tables, and the old way of consuming, processing this data into a different steps to do that machine learning process, what do you need to? The thought is, why do you need to go to multiple steps instead of doing it everything in a single, single place? So that's basically a topic for discussion today on this presentation. So if you look at a traditional machine learning process setup, right? It's basically whenever we talk about machine learning, there are so many components come into picture. Like how do we collect data? So the data will be coming from a traditional RDBMS database, structured as well as unstructured data from Facebook, Twitter. There are a lot of data we are pumping into a collecting in a place called like a streaming into a Kafka or streaming process, and then using a Spark, we process the data. Right, that's where we build machine learning models. And then again, once the data is built from machine learning model, we'll store it in some kind of a MapB database, like a JSON database, MapR system. Then we send it to analyze, right, using the Spark SQL or Apache SQL or any BI business intelligence tools. So if you look at any setup like this, it's basically it's a time-consuming process, and you need to have a lot of skill set. You need to be basically you need to be an expert in Python or Java, whatever the tools programs you use, and then you need to expertise hardware, right? You need to set up a different hardware components to process all this data from end to end. So this is the traditional way we are using right now. All the machine learning setup, every industry is going through right now. The setup is now. If you look at another perspective, the thought is, if my data is sitting in a single place, right? Why not I go to the place and do my machine learning process there itself, right? And this is where a lot of new databases. As one of the presenters said, in-memory database like DB2, IBM DB2 Blue, which is basically with the new version, they made the databases like AI, artificial intelligence database, wherein we introduced a lot of machine learning processes inside. So that the thought is, you don't need to go through shopping various products. You do all your if you have your data, if you have a data sitting in a system, jump onto the system and do all your machine learning process there itself. You don't need to go anywhere else. So and if you look at the setup, it's a very simple, and all the data is sitting there using the AI layer. We do all kind of entire process there itself. That's a thought. So if you look at DB2 right now in the 11.5, right? There's a new version, 11.5 Fixpack 6 onwards. This in database machine learning is introduced. And if you look at the way, right? They explore, pre-process, train, and evaluate and interference, right? All these steps involved in this machine learning, everything is done within this DB2 using various set of, I'll show you what we do, but all these steps can be used within the DB2 using a various set of stored procedures, right? So by looking at the setup, so this is basically a setup we did on University of Oregon, and in the data center we got a IBM Power 9 server. And on this server, what we did is we installed 11.5. When I said that, I'm not sure I said Fixpack 6, it's a Fixpack 5, right? DB2 11.5, Fixpack 5. So basically what's happening is this is the setup. We set up the DB2, we installed DB2, we set up the database. And one of the core setting is DB2 enable ML procedures. That's the option we need to set it. Once you set it, and you set up a database, basically the database is enabled for artificial intelligence, and it can do the any kind of machine learning process, right? So this is basically a setup. I'm just showing that syntax and the setup on the server. So these are the things. The next few slides, I'll just I'm not going to go detail, and these are the set of stored procedures where we have. So basically, in any machine learning setup, right? When you want to split data, when you're splitting data from a big data set to convert into a training and train and test, and this is the stored procedure will be and the split data. When I saw split data, that's the procedure we'll be using, and the rest of the procedures will be used for various different processes, as I said in that as it's explained in the detail. I mean. And data exploration, you want to visualize data, use the stored procedure. It will summary of, it will show, basically visualize all the data, basically what is the data type and what is the mean value, average value, all these things can be predicted, used, formed from this procedure. And these are the very powerful model building process that we have within DB2. And so all this, when you're a machine learning expert, all this decision trees, linear regression, naive Bayes, and k-mean clustering, right? All these processes can be natively done within the DB2 using this respective stored procedures, right? This algorithm is already built in, and we can just go. You can just go and consume them, call them with the data set, and it will do the work for you guys. So this is the one traditional setup I'm looking for. So the idea is, so as I said, we are a logistic company. We have 8,000 plus trucks, and the trucks are going in the on the highways, and trucks can get into any kind of I mean, we have sensors, right? We have built-in sensors, and in one of the presenters said coming up with a new AI cars, right? All the new cars are going to be completely AI with computers enabled, and it's fully packed with so much sensor data we get from, right? So the idea is the trucks we get engine from the engine continuously. The data get fed from engine for the maintenance reminders, tire tread wear, as well as the engine failures. What is the condition of engines and braking? So many information we gather, and we feed. The idea is we feed into a 11.5 database, directly into the 11.5 database, and then continuously monitor the data. Basically based on, if the truck needs a maintenance and there is an alert comes from the truck, and based on this past data, the classification data, it will send an alert, and then based on the alert, we will take an immediate action, so that the truck we don't need to stuck the truck in a highway or get into an accident. Who knows? So many things can happen when it goes to a failure scenario. And before that happens, we can catch up the the flag and alert the driver to make sure that you get into a safer site or maintenance place. So this is basically the setup we are talking about. And this system, again, we are experimenting this database in University of Oregon with this database. I'll show you some of the test data, what we are doing in Oregon. So in this particular scenario demo, what I'm showing is it's a set of data set, right? I mean, if you look at the data, this is I captured a set of features, right? I mean, for example, the vehicle temperature, with the measurement temperature, vehicle speed, vibration, engine load, coolant temperature. I mean, all kind of name for it, right? We're capturing all these features from a truck, and then we label it with the maintenance flag, right? If these conditions matches, and we will label it, and this is a labeled. This is a labeled data set I'm working on, and so the idea is use this data set and label it, and once it's up and running, and any new data set coming in, it will correspondingly it will evaluate what is the maintenance flag required, and then it will alert the system. So this is a sample data set, and which I pulled from GitHub, and basically this is the predictive maintenance optimization stack. And then if you look at it, this is a sample, I mean, data set outside coming directly from the truck. So what we did is in this based on as I mentioned earlier, based on the process procedures. So we did use these procedures, right? These procedures, and we ran the data set into the procedures, and we got the results set this way, right? So data exploration step 1 is done through summary 1000, wherein we got basically 7,504 records, the test records, and then for the transformation, we split the data into 2, as I said. For one is for training, another is testing, and with the 0.95 is the fraction. So we split the data into 2 different data sets. And we used, in this case, we used a classification algorithm, which is a naive-based, very powerful classification model. So we use that model to train, right? To train that data set, what I have inside, and so that a model will be understanding what the data it is. So this is how model is get trained, and we can print the model, how the model looks like. And once the model is printed, I will be running a predictive analysis, right? With the new data set, new incoming data set, I will run the predictive analysis on what the maintenance flags is going to be without labeling it. And then at the end, I'll print a confusion matrix. Basically, this is the model evaluation step, wherein that it will print how many records got predicted correct and how many not. So based on this this outcome, right? I mean, in this case scenario, out of 375 records, only 61 records was not giving me the right number, or predicted wrong. So what I will do is there's a 16%, and I will, in this case kind of scenario, I will reevaluate the model with the more data set, and make my entire purpose is to bring down the difference as less as possible, so that I can use this model like close to 95% accuracy, right? That's the idea. So these are the steps we used, and we ran through this predictive analysis, right? So just any question, guys? Anybody has any thoughts and questions before jumping onto a demo? Okay, I will take it. Ganesh, if you want to gather any questions, let me know. Hello. Ganesh, can you hear me? Okay. Hey, Ganesh, can anybody hear me? Or I mean,
Yeah, we can hear you, sir. You can continue with your session, sir.
okay, sure. Thank you. Just make sure that Okay, thanks, guys. So this is the basically setup, guys. This is our. Do you see my screen, which I shared right now? Green screen.
Yes, sir.
Okay, sure. Thank you. So this is basically the server. What I'm talking about. So this is where we set up the DB2, right? This is the AX 7.1, and which is running right now on Oregon. And right now, what we have is DB2 11.5 Fixpacks 6 on the server. So for this, the setup is pretty simple. So what I'm doing right now is this is basically so to set it up. So this is basically a table, right? We are creating a free table for that to get that. First, we build a table and import the data into the table. And so this is the basically fleet name base is the input table. And we have the data set. What are the data set we are receiving? We are inserting into first step is we are inserting the table. So if you run this. Okay, so what we did right now, we set up a table, right? Input table, and then we from that data set what we received, we imported like 7,500 records into this table, right? So we do select count star. Okay, so it's 7,500 records sitting in this inside this fleet name base table, right? So the next step is what we'll do. We'll start calling the, as I shown the presentation. We'll use this set of stored procedures, right? We look at it. We will drop anything existing one, and we will using the stored procedures. We will build this. We'll split the data into two different data set, and we build the data model, right? We build a model using the naive Bayes algorithm. So this is a naive Bayes algorithm, and then we'll do the run a predictive naive Bayes algorithm and see how many records are getting matched, and then we will, at the end of the process, we'll build a confusion matrix, and we'll tell you that how many records get matched and then how many didn't match. So that's an idea. Now, if you run this. So the process is running now. I mean, it takes it. So for me, with the loss test, it took like a little over 5 minutes to run through this build, basically to build the model. And why it taking 5 minutes? Because if you look at the data set, what I have, look at the data set, I have so many features, right? So the model has to go through all these columns and come up with a random, go through the naive Bayes algorithm and build the data set. So that's why it takes a little longer. So that if as you keep the features less, the model will be much faster, and if you keep the feature more, the building will be it takes a little longer. based on that, setup. So if you have any interested in anything, like, I mean, these servers, we are going to open up for more use case scenarios, and we welcome more folks into jump on and build, run through different analysis and building new models, and you name it. You can do so many things within this, on this server. So when the model is building, I'll show you what, based on the previous output, I'll show you some of the. So this is a previous output screen. So if you look at it, we drop the tables and we split the data into two, right? With the 7,504 rows, we split into two different data sets, one for train and one for test. And then we build the model, right? So the model size, it says 15,292 once it gets built. And then we print the model here, and this is where we do that predictive analysis, right? Using just by calling a predictive name base. And then once the model, the name base is built, it will go to the, I'll show the results, And then here I'm comparing, basically I'm comparing between that predicted value with whatever the result set from the previous actual result set. I'm comparing the results. And then at the end, I will be building a confusion matrix where I'll tell you that how many records get matched and how many didn't get matched, right? So the model is still building. I will show you once the model built, we'll see the result set right now. Okay, I think it's done. Just now, as we speak, it's done. So in this scenario, in this, so this is running on a Power 9, guys. This is again Power 9 server, and you see that performance, right? It took almost 5 minutes to build this model, and again, this based on the complexity we involved in this building, and at the end, it will tell you that, right? How many records get matched here, and we are getting like a close to. In this kind of scenario, we have 13% difference, right? So which is very good. It's improved a lot. So you keep building the model with different data set, and you keep that percentage, difference as small as possible, so that your model will be, will be more kind of more accurate for upcoming testing. So with this, what I'm trying to show is what I showed you so far is you don't need to be a Java or Python or an expert. And even if you're a Python expert, still you can use Python codes within DB2, like external function. We can use it, and then we can build, build this model, right? So you can use, but still, what I'm trying to show is even without just by if you have a data set, you can run through this set of stored procedures, and you can do model building within, you don't need to be expertise in different programming language or stuff. So with this is a demo, guys. If you any questions, please ask right now, or I will just go to the last step here, last presentation, last title, which is the feature use case scenarios. So the thought is here is the thought, right? What are we going to do with this predictive modeling, right? So with this, we can answer so many questions, like how long, if my truck is going in the route, how long it can run without any maintenance. And for example, we hire a lot of drivers, right, in our company, and based on the features, once we have the right data set for the different kind of drivers future, I can accurately say how many drivers can quit in next 30 days, right? Based on the predictive modeling. And what is based on the past revenue, I can say what is the turnover, what will be the turnover in future, and what kind of accident prevention we can come up with, and tire tread and battery life. There's so many things, life for the trucks. So all this data can be predicted and accurately addressed to the respective drivers or respective in charge, and we can keep keep the trucks up and running all the time, and without breaking, without having a stopover or delay, right? So with this, I'll open it for questions and answers. And anybody have questions, feel free. Any questions I can take. And as I said, we are opening this server for more learning and analysis, and for different things. And Ganesh can speak more on that. Ganesh and Dr. Samit can speak more, but this is what we are kind of, right now we are there in
Siva, I have a quick question. Thank you for showing the demo on the University of Oregon server. Can you tell me if the DB2 was running on the spectrum scale file server, the GPFS partition?
Yeah, so that's a good point. I mean, so this is running on this server, yes, Sirius-AX, right?
Yes.
And when I look for the only thing is I will say is since we had one disk on that, only one disk, and that's why I think it took like 5 minutes to process, because there is a lot of disk I/O. But
sure. Okay, so you're using the local NVMe disk. That's what I wanted to know.
Local
disk.
The local disk. I'm not using a GPFS, but this is what you're talking about, right?
Yes.
Yeah.
GPFS, well, that could do even better speed ups, but thank you.
Oh, okay. Sure. I mean, right now, if you look at just they're all pointing to the local one second, I'm sure. Local disk, which is the DB2 data, right? This is the dev this data. And then,
sounds good.
Yeah. So this is the what are the data which is DB2 data? That's what it's right.
Sure.
Thanks, Samir. I mean, we
and
can
for
do
large
more
data
testing.
sets, the GPFS would be great. Yeah.
Okay. So maybe that's the next step. Maybe I can move this database to GPFS, and then later let's find out how much performance we can gain. That's one.
Sounds good. Thank you.
Yeah, sure, sir. Thank you.
Yeah, this is Dr. Vincent, Professor, sir. It's a very nice presentation. Could you hear me, sir?
Oh, sure, sir. Yeah, go ahead.
Yeah. It's a very nice presentation, and you've given a very real-time demo, so that the people who are seeing this, the research scholar, they can do some work with this machine learning, that is VM classification and other algorithms too. Is there any the research scholar could work along with you, or any people who can create a new model? I think you talk about is it open?
Yeah.
Open source.
Yeah. So Dr. Vincent, thanks for asking. That's a very good question. So the thought is right now, basically right now we are consuming this model, right? As I was showing you earlier. So these are the model, right? DB2, IBM provides. These are already written models, algorithms.
Yes.
And this is IBM provides this model directly on right from the database, right? And you can use it.
Yeah.
If you want to build from scratch, you can build, for example, with the Python and code. If you want to build, still you can build the Python code. And as Dr. Samit said, in this server, all the machine learning functionality is installed. I mean, the set of all the tools got installed, and including Python. And you can call the Python code within DB2, right? Within DB2 as an external function, and still you can do predictive analysis. Yes. To answer the question, and if you are building apart from these models, if you are coming with the new models, definitely we can, IBM helps.
Yes. Thank you. It's a nice presentation.
Thank you. Yeah. And as I said, just for a data set for beginners, they don't need to know anytime when you talk about machine learning, there are so many complexities coming to picture. And here we are just directly using these procedures. They will, this is how it works. And they can enhance their knowledge set by building, as you said, new algorithms.
Thank you, sir. I think we can contact through mail and along with Mr. Ganeshan, sir, and we do some work with you. Thank you.
Sure, sir. Yeah, I'll share my email and let Ganesh, coordinate.
Yeah. Thank you, Shiva. Is your presentation completed?
Yeah. I'm
Yes, sir.
done.
Yes, sir.
Oh, okay.
Yes, sir. Finished.
Yes. So, any other questions for Shiva? The real time, the machine learning model, and all the stuff, through enterprise computing. This is what a lot of enterprises going to apply AI into their platform. Any other questions? Anyway, I'd like to invite Dr. Pratik, Dr. Sangaram, to say a few words about the event